The diagram shows a trapezium PQRS. PQRS. QR is parallel to PS, and PS is 4 times QR. PQ is P, and QR is Q. So vector PQ is P, vector QR is Q. Find in terms of vectors P and Q the vector RS. Giving your answer in the simplest form. The point A lies on PR such that PA, the ratio of PA to AR is 3 to 1. And the question is QAS a straight line? Okay, so using the diagram, so vector RS we're asked to find in part A. So this is this vector here. So we'll draw that on. So so one way to find vector RS is to go to RQ plus QP plus PS. Now, it's always a good idea to write those letters out first. The letter here should be, the first one letter here should be the first letter given in the question, and the last letter should be the last letter. So it's just finding a different route. Now, so you're going against the arrow here, so that will be minus Q. You're going against the arrow here, so minus P. Now, we're told that PS is 4Q because we were told that PS is 4QR, and this is vector Q, so this is parallel to it, so it will be the vector 4Q. So we need to add 4Q. Now 4Q minus Q, just like normal algebra, it will be 3Q minus P. So that's the answer for part A. Now, in part B, we're told that A is on this line PR such that PA to AR is 3 to 1. So this is not into scale, so we put it on here so that this looks like 3 and this looks like 1. We'll call that point A, and this is 3 to 1, and we now need to find the vector QA. Right, and if we find the vector QA and then the vector QS, and we're asked to determine whether QAS are on a straight line, if they are parallel vectors, because Q is the same point, then those 3 points are said to be in a straight line, or they're said to be collinear. So just repeat that. If we find the vector QA and the vector QS, if we can prove that the vector QA is parallel to the vector QS, because Q is a common point to both vectors, then the points Q, A, and S must be on a straight line. So finding the vector QA first of all. So QA is going to be the same as going QP plus PA, which is going to be QP plus 3/4, because this is in the ratio of 3 to 1, so it's 3/4 along the line PR. So that's going to be minus P plus 3/4. Now vector PR, so vector PR is going to be the same as doing P, Q plus QR, which is going to be P plus Q. So in here, we're just going to put 3/4 in brackets of P plus Q, and then we just expand this like normal algebra. So we're going to get minus P plus 3/4 of P plus 3/4 of Q. So so that's going to give 3/4 of Q, and then minus P plus 3/4 gives me minus 1/4 P. Now there's a common factor of 1/4, so we'll take that out, and we will be left with 3Q minus P. Now, the reason for factorising is we're going to have to compare it now with the vector QS, which is this one, because we want to know if they're parallel or not. So QS is the same as going QP plus PS, or you could have done QR plus RS, it's the same thing, plus PS. So that's minus P plus 4Q, which if we rewrite that as 4Q minus P. Now, if we look here, we've got 3Q minus P, and here we got 4q minus p. Therefore, these two vectors are not parallel. So note that the vector qs, which is this one, is not equal to some multiple of qa. Alright, so just look again, that this one here is not the same as this part here. So therefore we're saying that qs is not equal to some multiple, the multiple being k, of qa. Therefore qa and qs are not parallel. So if they're not parallel, then therefore qas is not going to be a straight line. Okay, so this has been a video to show you how to determine whether 3 points are in a straight line or not. I hope you've understood, and I thank you very much for watching.